Hello, today we are going to learn about vectors and scalars. So to begin with, we are going to define a scalar as well as a vector. A scalar is a quantity that is magnitude only. A good example will be your mass, length, temperature, or speed. We will say a boy has a mass of 60 kgs. 60 kgs is magnitude only. A vector is a quantity with both magnitude and direction. For example, force, displacement, acceleration, velocity, or momentum. I will give an example of force. We can say a donkey applied a force of 20 newtons to the east. 20 newtons is the magnitude and going to the east is the direction. We are going to look at vector notation. Now, vectors can represent the XY plane. They can be represented on the XY plane. Now, in this diagram, we have our vector XY, which is when we are moving from X going to Y. And that vector xy is a magnitude of x as shown in the diagram. We have said earlier on that a vector can be represented along the x and y planes, along the x and y axis, sorry. So this means to say that when we want to move from x to y, other than moving directly from x to y along this line, we can go from along the x-axis 1, 2, 3, 4 units and 3 units going up. Now, the movements that we have made along the x-axis are represented by B, and the movements we have made along the y-axis are represented by A. Now we can denote our vectors in this form. We can write them in this form as x and y coordinates. For example, in this case, our vector xy would be BA, since we moved B units in the x direction and A units in the positive y direction. We are going to calculate later in the video the magnitude of a vector. Remember, we said that a vector has magnitude and direction. The magnitude of a vector x, y can be denoted by these two lines. So when you put these two lines all the time, it shows the magnitude of a vector. And the arrow that's on top shows the direction of the vector. In this case, x, y, we are moving from x to y. So we have the magnitude as well as the direction. As we are talking about vectors, we have to know that there is something called an inverse vector. An inverse vector is a vector of equal magnitude to the original, but in the opposite direction. For example, we have AB pointing downwards and AB pointing upwards in these two examples. The magnitude of the first one is x, and the magnitude of the second one is negative x, since it's pointing to the direction that is opposite the first one. These are referred to as inverse vectors. So negative AB is the inverse of AB. Negative showing that they are in different directions. We can say negative AB can be shown as BA because AB, negative AB means we are moving from B to A, right? Negative AB means we are moving from B to A. So B to A is the inverse of AB. Now, we said that a vector has magnitude and direction. The magnitude can sometimes be referred to as modulus, which we have said that it is shown by these two lines. So the modulus of a vector x is written as this, with the two lines showing the modulus of the vector. The modulus, or the magnitude of a vector, can be calculated using the Pythagoras theorem. As we saw in the figures above, that a vector can show a right-angled triangle, and the vector becomes the hypotenuse of the triangle. Since we have a right-angled triangle, we can use the Pythagoras theorem to find the length of the hypotenuse, which is our vector. As shown on this diagram, we have a right-angled triangle, and the magnitude of our vector xy can be calculated using the Pythagoras theorem, since xy is the hypotenuse of our triangle. This is a representation of the Pythagoras theorem, which you're going to use to find the magnitude of our vector. Now, there is something called scalar multiplication. A scalar quantity is just a number. It does not have direction. And this can be used to alter the magnitude of a vector, but not its direction. For example, we have our vector x. We can multiply it with any number to give us another vector. In this case, we are multiplying x by 2 to get a vector that's 2 times longer than the original vector. In the diagram above, the vector of magnitude x is multiplied by 2 to become magnitude 2x. If the vector x starts at the origin and ends at the point 4, 4, then the vector 2x will end at 8, 8. So basically what we are doing is multiplying the first vector by 2. You see 2 times 4 is 8. 2 times the second 4, which is the y coordinate, is 8 again to give you 8, 8. We can show it in column vectors. These are called column vectors, where this is the x coordinate and this is the y coordinate. So for 2x, we will get 2 times the column vector. You multiply the 2 with everything that's in the column vector. So 2 times 4 will give you 8. 2 times 4 will give you 8.